Welcome back to 8 Minute AI. I'm Becca.
I'm Michael.
And I'm Garvin. As we discussed in the last episode, generative AI or Gen AI uses deep learning and neural networks to learn the complex patterns of language and then mimics those patterns to create responses to your questions or input. In today's episode, we're exploring large language models or LLMs, which are the brains behind the text based generative AI models.
Yeah, LLMs and text based Gen AI are really what kicked off this AI craze in recent years. They can be used to assist with various tasks such as writing, summarizing, ideation, or even research. Businesses are using LLMs for a bunch of different things, things like customer service chatbots, content creation, marketing, knowledge management, document search, data analysis and reporting, and even as programming and software development assistants.
Yeah, LLMs are AI systems trained on massive amounts of text data. More recently, multimodal LLMs also incorporate image, audio, and video data, which are processed to be treated similarly as text. These AI systems take input, called a prompt, and generate output in a human like conversational response.
We mentioned last time that traditional autocomplete was limited to only looking at a word or two to predict the next word. LLMs actually look at entire sentences, paragraphs, and even book worths of input to infer intent when predicting the next word.
That's crazy. LLMs can take in so much input at once. If you think of all the words in the dictionary, let's say there are 300,000 in the English dictionary. That's a long list of words, but not a big amount for a computer. Now think two word combinations. That's essentially 300,000 times 300,000 or 90 billion. Way bigger, but still not too much for a computer. Try adding three words, and you're looking at 27 quadrillion three word combinations. Now we're talking numbers too big for an autocomplete system, and we're only at three word combinations.
Wow, yeah, those numbers quickly get out of hand.
Yep, but since generative AI and LLMs use neural networks, it's not storing that many lists of words. The system pumps the entire input into the neural network where it's all converted into numbers and operated on much more efficiently.
And rather than breaking down sentences into words and predicting words, it's actually breaking down sentences into what are called tokens. Think of tokens as syllables. They're not quite, but similar. If we say the English language has about 300,000 words, most LLMs are using around 30 to 50,000 tokens today. It does this by reusing common pieces of words. For example, the word appetizer could be tokenized into appetize, ending at the Z, and then a separate token for the ER suffix. That way, the ER suffix can be reused for other words instead of needing entirely new words for everything ending in ER. Repeat that for the ing suffix, un prefix, and so on. Even though we're now using four tokens for appetizer, appetizing, and unappetizing, we can reuse three of those four tokens over and over again to create new words.
There are tokenizer websites where you can input text and see how the text breaks into tokens for various models. We'll link to some of those in our show notes, but we'll use token and word interchangeably from here.
The core idea behind an LLM is simple. It predicts the next word based on the ones before it, one at a time. If you type, a peanut butter and jelly sandwich is made with, a basic autocomplete might only look at the last word, which is the word with, or maybe even a few words before it. That's going to be hard to accurately predict the next word from jelly sandwiches. But an LLM looks at the entire input. It gives more weight to keywords like peanut butter, jelly, and then less weight to filler words like a and is. You can already see how peanut butter jelly gives much more context than jelly sandwiches. That fuller context leads to much better predictions.
And now for the prediction part. A simple method might always choose the most likely next word. So if you prompt it with a peanut butter and jelly sandwich is made with, it might always say bread, fast and consistent, but boring. To make responses more interesting, LLMs often pick from several likely next words, not just the most likely. That's how you get variety, like white bread, whole wheat, or a slice of sourdough. Some models go even further, exploring multiple possibilities before selecting the best overall response, called reasoning. And the cool part is, you can often control how the LLM behaves using settings like temperature, top P, and token penalties. We'll cover those in another episode.
And now, since it's not taking the highest rated token every time, you'll get more creative recipes. Maybe it adds bananas or swaps out the bread for tortilla. It might even go nuts and suggest crunchy peanut butter instead of smooth.
Yum. Though sometimes those creative outputs can turn into hallucinations or even weird responses. For example, if it says a peanut butter and jelly sandwich is made with mayonnaise, well, that's not that commonplace. But it might have seen an old article mentioning that combo during the Great Depression or a few websites that have recipes involving the combination. From a data standpoint, peanut butter and mayonnaise could all be linked.
Well, I do not want to try mayonnaise with my peanut butter. So, what can be done to avoid hallucinations and biases?
Well, the data used and the training performed are important aspects of LLMs. It's very similar to databases, garbage in, garbage out. The risk of hallucinations, biases, and misinformation can be reduced with three things. 1. Training data that is curated or fact checked. 2. Topic specific models such as a coding model, medical model, or legal model. And 3. Verification layers such as fact checking layer that checks the output against a consulting database.
Okay, so we learned that LLMs generate text by recognizing patterns in large data sets, making them useful for various tasks like writing and summarizing.
But LLMs don't truly understand text, they only reflect what they were trained on. That means they can produce biased or inaccurate results. So, it's really crucial to manage both the data and the training to reduce risks of hallucinations.
Next time, we'll talk about how to get the most out of large language models by providing well written input or prompts through the practice called prompt engineering. In the meantime, be sure to hit subscribe and take a moment to share this podcast with others who may enjoy learning about AI.
And if you're listening on Spotify, don't forget to vote in today's Spotify poll and leave us a comment. All of that engagement really helps others find the show.
Join us next time on 8 Minute AI.
Bye.